Hello, good afternoon, everyone. Thanks for coming to this session. My name is Rui, and I'm a scientist at IBM Research. Today, I will be talking about one of the research projects we've been doing regarding adding new big data storage capabilities to OpenStack Sahara, which is a relatively new OpenStack service. Okay, and before we dive into details, I want to emphasize that this is a very early stage research project, and we really welcome the constructive criticism from the community to help us do a better job on this project, okay? So I will give you some background in terms of big data and Sahara, and then we move forward to why we need to extend the storage model currently in Sahara. And I will illustrate how we can do that using an example storage system, which is called IBM Spectrum Scale, and formerly known as IBM GPFS. Okay? So in the past couple of years, we've been blessed with an enormous amount of innovation in the big data analytics space, and there are a whole bunch of, whether for better or for worse, there have been a whole bunch of big data models coming up. We have the most well-known one would be MapReduce. And then there are a number of others such as Spark, Giraffe, and Storm. If you're not familiar with big data, you can think of MapReduce at a very high level as a means for you to process a large amount of data in parallel. So imagine you have a big file of 30,000 lines, and you have 10 VMs to process this data in parallel. Maybe you want to do a word count, maybe you want to do some sentiment analysis based on the data. So what MapReduce allows you to do at a very high level is really to let you partition that big file into 10 chunks, and then every one of your VMs would be responsible for processing one of the 10 chunks. Okay? Looking at some of the other models, they all fall at a high level, they all try to pursue the concept of parallel processing, but they have different emphasis. Spark is more focused on in-memory computing, it's focused on the algorithms that iterate many times. Giraffe is more focused on graph, and Storm is more focused on receiving a stream of data live and then processing as they come. Okay? And looking beyond the big data models, we have a very well-known infrastructure called Hadoop, which is to me, it's a support ecosystem for us to run all of these big data models. So Hadoop basically provides a resource provisioning mechanism where, as you can see on the screen, you have a central control node that does the scheduling and assigns resources to different nodes that you have in your cluster. And then in every node, you have some local control to help you spawn up tasks to process your data in parallel. Now Sahara, as I said before, is a relatively new OpenStack service. The reason why we need Sahara is that configuring a Hadoop cluster is an enormous task. You have to configure your VMs, you have to configure your underlying infrastructure, you have to make sure to set up your master node, your slaves, you have to ensure that the master is talking to the slaves. Once you have all that set up, there are hundreds of parameters in Hadoop that can affect its performance, and all these have to be given a value for the cluster to function properly. So it's not a simple task to set up such a cluster. And what Sahara strives to provide is a one-click service, or maybe several click service, that allows you to bring up an entire Hadoop cluster using OpenStack components. And I'm assuming many people in the room and in the audience know a fair amount about OpenStack. So Sahara will interact with the rest of the OpenStack services and automatically bring up an entire Hadoop cluster running in the Nova VMs. A little bit more background. So this is a high-level general flow of how Sahara will work. Okay. First, you choose some kind of Hadoop version that you want to deploy. And then you say, okay, what kind of nodes or VMs do I want in the cluster? And once you have given that specification, you can basically launch the job. in the cluster you just built. Okay. Now, why do we need additional data storage support in Sahara? It's because currently it only supports 2 big data storage models. One is the HDFS, a lot of people would know that, and then we have the object storage called Swift. There are drawbacks with having just 2 models, because what if you have existing data in other storage systems? You cannot really use Sahara to bring up a cluster to process data in those environments. Furthermore, the current 2 storage systems, they are now perfect. They cannot do everything. And there are certain capabilities that can be provided by other storage systems that we want to leverage. So our proposal is that we want to pave the way of adding additional storage models into the Sahara framework so that we can process any big data sources that we can find. So this breaks down into 2 steps. The first step is that we need to be able to automatically configure whatever new storage system we add into the environment. And then we need to extend the Sahara GUI to expose this new storage source to whatever analytics jobs we want to run. Okay. I'm going to describe how we're going to do that using an example IBM storage system known as Spectrum Scale. There are a lot of perks that come with Spectrum Scale. The most notable one is that we have a uniform namespace, meaning that one copy of data, multiple access points. It can be accessed through the POSIX interface. It can be accessed through object, many other things. And then there are various enterprise support, tape compatibility, and all the nice features that you would expect from a mature product. So I'm going to show how we're going to integrate IBM Spectrum Scale into the existing Sahara framework. As you're seeing on the screen, we have a Hadoop cluster up with Nova VMs. Every blue box is one Nova VM. Inside it, we have 2 types of activities. The first type is the box to your very left. That is the control node. So that runs the Hadoop resource manager. It's basically the scheduler that understands the current state of the entire cluster. And then we have the slave nodes, the slave VMs, that actually do the parallel processing. And in these VMs, we have the Hadoop node manager, and then we have a Spectrum Scale client, which understands how to talk to the Spectrum Scale servers at the very back end. And once you have this environment set up, then the Hadoop processes are going to write data to the Spectrum Scale client, which will then send the data to Spectrum Scale servers, where they are permanently stored and backed up and everything. Okay? One of the key challenges here is that you remember Sahara is about automation. So we have to be able to automatically build any VM image with all this nice stuff inside. Once the VM image comes up, it has to execute a script to launch all the corresponding services for the entire cluster to function. So that's the additional value we are bringing to Sahara here. This screen illustrates what the end product would look like when it's actually finished. So when you create a new Hadoop cluster in Sahara with our prototype, what you would be able to choose is that, okay, well, I'm going to create a bunch of nodes with the Spectrum Scale client running inside. And you click create, and it's done. And we handle all the messy stuff behind the scene. This is showing, okay, once you have the cluster up, I can now specify Spectrum Scale as an additional data source where we pull in data to do our Hadoop analysis. Okay? And that will be all for me today. Thank you very much for your time.